Um, so just in case for someone that missed the first half of it, so I went through one example with sine 105 degrees using the sum of angles formula there. And if we want to find tangent alpha plus beta, we're just going to convert it to sine and a cosine. Now, for this specific example given here, we are given that sine alpha equals 3/5 for alpha is from 0 to pi over 2, and the cosine beta equals -5/13. Beta is from pi to 3 pi over 2. So we want to find sine alpha minus beta and the other two. When we find sine alpha minus beta, we're just going to apply the difference of angles formula, which is sine alpha cosine beta minus cosine alpha sine beta. And sine alpha we already know, cosine beta we also know. We just need to find cosine alpha and the sine beta. And we're going to use a right triangle to find cosine alpha. We know that sine alpha is equal to 3/5. So we're going to assuming the hypotenuse is 5, the opposite side equals 3. And from there, we can calculate the adjacent side to alpha, which is going to be 4. So cosine alpha is going to be 4/5, and that's correct because the angle is in the first quadrant. Cosine alpha is positive. Now we need to find sine beta, and the beta is in the third quadrant. Again, I'm going to create a right triangle there. And I know that cosine beta is -5/13. So I'm going to call the hypotenuse 13, and the adjacent side is going to be 5, and it's negative in the negative axis direction. And then now we just need to find out the opposite side of beta. So 5, 12, 13. So the opposite side is 12. And now we can find sine beta, which is going to be opposite 12 over hypotenuse 13. But remember that this is the angle in the third quadrant. It's from pi to 3 pi over 2. So the sign has to be negative. We just have to add a negative sign there. So now we have all the terms. We can just simplify. So the denominator is going to be 5 times 13. So that's going to be 65. And the numerator for the first one is -15. For the second one is negative. So minus 4 times -12. So that's plus 4 times 12 is 48. So if we simplify this, we get 33/65, and looks like we cannot simplify further. So that's sine alpha minus beta. Any questions on this one? So this one is a little bit challenging from what we did earlier, the previous example, because that problem we know sine and the cosine of each of the angles. But in this one, we only know sine of alpha. We have to find cosine alpha. We also have to find sine beta. And we have to be careful with where the angle is. And suppose I want to find the cosine alpha plus beta. Using the formula, that's cosine alpha cosine beta minus sine alpha sine beta. And then we're just going to plug in what we know. We know that cosine beta, but we don't know cosine alpha. Cosine beta is -5/13. And you probably said, oh, didn't we find it? That's correct. So we found it in the previous part. We can actually plug in cosine alpha, which is 4/5. And then minus sine alpha, which is given, 3/5. Sine beta is not given, but again, in the previous part, we found out that sine beta is -12/13. And if we are careful here, we can again find the sum. So that's going to be 5 times 13 is 65. So we get -20 minus 3 times -12. So that's positive 36. So we get 16/65 at the end. So that's cosine alpha plus beta. And then if we want to find tangent alpha plus beta, I'm just going to rewrite it as sine alpha plus beta over cosine alpha plus beta. And I'm going to take a sort of a lazy step because I already found cosine alpha and the beta. I'm just going to plug in directly 16 over 65. But what about sine alpha and beta? We didn't find that. We can find it now. So that's the sine alpha cosine beta plus cosine alpha sine beta. We just have to plug in those values. And that's going to be sine alpha 3 over 5 cosine beta negative 5 over 13 plus cosine alpha 4 over 5 sine beta negative 12 over 13. And all divided by 16 over 65. And if we simplify the numerator, so that's going to be negative 15 plus negative 48, so minus 48 over 65 divided by 16 over 65. And so that's going to be negative 15 minus 48. So that's going to be negative 63 over 65 divided by 16 over 65. So we get, we multiply by the reciprocal, so we get negative 63 over 65 times 65 over 16. So we get negative 63 over 16. So the process is really the same. It's just right now we have more steps to calculate, more terms to find. Any questions on this one? All right, but again, like I said earlier, you should memorize the sine alpha plus beta and the cosine. You should have those memorized because it's going to save a lot of time in the future. The tangent, don't even bother to memorize it. All right, so let me move this to the left a little bit. Okay. All right, so the next example, what we're going to do is we're going to use the sum and the difference of angles formula to verify identities. So it says verify the following identity, which is sine alpha minus beta divided by cosine alpha cosine beta, and it's equal to tangent alpha minus tangent beta. So if you remember what we did with previously, if we want to prove whether identity is true or whether we want to verify if it's true, we cannot multiply, we cannot work on terms on both sides at the same time by multiply by the denominator on both sides or divide by the same term on both sides. We have to keep them separate. So in this case, it doesn't matter. You can work with the right-hand side or the left-hand side, doesn't make a difference. So suppose I want to work with the left-hand side. So I'm going to have sine alpha minus beta. I'm going to expand that difference. So that's going to be sine alpha cosine beta minus cosine alpha sine beta. And that's all going to divide by cosine alpha cosine beta. And from here, what we're going to do is we're going to separate the fraction into two. So that's going to be sine alpha cosine beta divided by cosine alpha sine cosine beta. And immediately we can cancel the cosine beta and minus cosine alpha sine beta cosine alpha cosine beta. And we can cancel the cosine alpha in the second term. And now if we look at each term, we get sine alpha cosine over cosine alpha. So that's going to be tangent alpha minus sine beta over cosine beta. So that's a tangent beta. And that's equal to the right-hand side. So the identity is true. Any questions on this? All right. So that's a sum and a difference of angles formula. So I just want to kind of go through the next part, which is, well, we begin with double angle formula. So there's already a formula you know for sine 2 theta or cosine 2 theta, but I want to explain, maybe not really explain, but I want to derive them using sum of angles formula. So 7.3 double angle formula. So suppose we have alpha equals beta. They're the same. So sine alpha plus beta is equal to sine alpha plus alpha. So that's going to be sine 2 alpha, right? But we also know that if we have sine alpha plus beta or sine alpha plus alpha, we can rewrite it using the sum of angles formula. So that's going to be sine alpha cosine alpha plus cosine alpha sine alpha. So that's just going to be twice sine alpha cosine alpha. So that's where we get the formula. You can write as, instead of using alpha, we can use theta. So we get sine 2 theta or x 2x equals 2 sine theta cosine theta. We don't even need the parentheses here. So that's sort of like a quick derivation of the sine double angle formula. And you can use the same approach to find the cosine double angle formula. So cosine 2 theta is equal to 2 cosine squared theta minus 1. I'm not going to do that, but if you're interested, you can use, again, you can say, okay, alpha equals beta, and what is cosine alpha plus alpha? It's the same approach. Now, the trick with I would say the trick, maybe the benefit of cosine double angle formula is that there's 3 of them. It depends on which one you want to use. So if we, at this point, we can replace 1 with sine squared plus cosine squared theta. If we do that, at this point, we're going to end up with a new expression, which is cosine squared theta minus sine squared theta. And at this point, if we replace cosine squared theta with 1 minus sine squared theta, we end up with another expression, which is going to be 1 minus 2 sine squared theta. So there are 3 equivalent expressions for cosine 2 theta, and you have to decide which one to use. Sometimes it saves a little bit more time. Sometimes it doesn't make a difference which one to use. But I would really recommend that you memorize at least one of the cosine double angle formulas and understand how to get the other one if you need to. Basically, just use the 1 equals sine squared plus cosine squared. Now the book has a formula for tangent 2 theta. I'm going to put it here, but I'm probably not going to use it in this form. Tangent 2 theta equals 2 tangent theta divided by 1 minus tangent square theta. I always use sine 2 theta cosine 2 theta whenever I need to. I don't memorize it. But the sine double angle formula and the cosine double angle formula, you should memorize them because it's definitely going to save time. All right. So here's the example. So given that tangent theta is equal to 3/4, and the angle theta is in 3rd quadrant, So we're going to find sine 2 theta, cosine 2 theta, and the tangent to theta. Well, we're just going to use the formula for each one of them. And then we know that sine 2 theta is equal to 2 sine theta cosine theta. Now, for this specific problem, we're going to assume that we cannot use the calculator at all, and we want to find the exact value. And you probably wonder, okay, can I just put that into the calculator, use inverse tan to get theta? That is totally fine if calculator is allowed. But for now, we're just going to assuming that's not the case. So from here, we need sine theta and the cosine theta, but we don't have either one. We know the tangent is going to be 3/4, and that angle is going to be in the third quadrant. So what we're going to do is we're just going to, so that's the angle theta. We're going to draw a right triangle. Let me make it a little bit bigger. So we're just going to use the angle theta there, the reference angle, to create a right triangle. And then we're going to assume that the opposite side is going to be 3, the adjacent side is going to be 4 to this angle. So this is the opposite side, we're going to call it 3, adjacent side is 4. And then we just have to be careful when we find the sine and the cosine. Before that, we need to know the hypotenuse is 5. And from here, when we write down the sine, we have to be careful, because if we just look at the triangle, we know that sine is going to be 3/5. But that's not the correct value, because the angle is in the third quadrant. This point has a negative x and a negative y. So the sine should be negative 3/5. And the cosine is going to be 4/5. But because it's in the negative axis direction, so it's going to be negative 4/5. And times 2 in front. And now if we simplify negative, negative become positive. So we get 2 times 3 times 4 divided by 25. So that's going to be 24/25. So again, just like a previous example we saw earlier, be careful because the angle is not in the first quadrant. So when we pick the value for sine and cosine, we have to be careful whether we take the positive value or the negative. And then if I want to find a cosine to theta, I'm going to use one of the 3 formulas. Doesn't matter which one. You can use 2 cosine squared theta minus 1. So that's going to be 2 times cosine theta. I already found that's going to be negative 4/5 squared minus 1. So if we simplify everything correctly, we get 2 times 16/5 minus 1. So that's 16/25 minus 1. So that's going to be 32 minus 25/25. So that's going to be 32/25 minus 25/25. That's going to be 7/25. That's cosine. And if I want to find tangent, for this case, it's a lot easier. Even if you were asked to find tangent to theta from the beginning, you can always use sine and cosine. Sine to theta, cosine to theta. So that's going to be 24/25 divided by 7/25. That's going to be 24/25 times 25/7. So that's 24/7. Any questions on this? Again, it's really just applying the formula. Once you know the formula, you start applying it, and it's just a matter of defining the correct value for each part in the formula. So let's look at another example, and we're going to verify the identity that's tangent 2 theta equals 2 over cotangent theta minus tangent theta. Now for this one, it's really, again, you could begin with the left-hand side, apply the formula in the book, or you can just rewrite it as sine and a cosine. But I'm going to actually try to work with the right-hand side. So that's equal to 2 over cotangent, which is cosine theta over sine theta. Is 1 over 10, if you like to put it that way. And then minus tangent theta, which is sine theta over cosine theta. And then look at the denominator terms. There's nothing we can do other than common denominator to bring them together. So that's what I'm going to do next. So that's 2 divided by the first term. I'm going to multiply with cosine, cosine. The second term I'm going to multiply with sine, sine. So I get 2 divided by cosine squared theta minus sine squared theta, and all divided by sine theta cosine theta after common denominator. And now I'm going to, instead of divide by a fraction, I'm going to multiply by the reciprocal. So 2 times sine theta cosine theta divided by cosine squared theta minus sine squared theta. And this is going to tell me that the numerator is going to be 2 sine cosine. So that's sine 2 theta using double angle formula. Denominator is cosine squared minus sine squared. So that's cosine 2 theta, the middle formula from earlier. And now we get tangent 2 theta, which is equal to left-hand side. Again, if you begin with left-hand side, you probably end up with the same. In about the same amount of time, or if you want to use the tangent double angle formula, it probably save a little bit more time, but I don't think it's going to make too much difference here. Any questions on this? So again, just a reminder that when we want to verify identity or prove identity, you don't want to cross multiply. You don't want to multiply both sides by the same factor, because if you do that, you're assuming the equation is equal. But we try to show it's equal, so try to keep them separate. All right, so that's the double angle formulas. And then now we have this called reduction formulas. Now the reduction formulas, you can think about they're coming from the cosine 2 theta. So recall we had cosine 2 theta is equal to 1 minus 2 sine. Well, I'm going to write down 2. The first one is 2 cosine squared theta minus 1. And then the second one is cosine 2 theta equals 1 minus 2 sine squared theta. And from here, we can solve for cosine squared and solve for sine squared separately. So on the left, if I solve for cosine squared, I get cosine 2 theta plus 1 divided by 2 equals, I'm going to take 2 steps. So that's equal to 2 cosine squared theta divided by 2. So I get cosine squared theta equals cosine 2 theta plus 1 divided by 2. So that's cosine squared. And then the second equation, I'm going to solve for sine squared. So I'm going to minus 1 on both sides and divide by negative 2. So I get cosine 2 theta minus 1 equals negative 2 sine squared theta. Divide by negative 2, so I get sine squared theta equals negative 2 In the denominator, cosine 2 theta minus 1. So if I move the negative 1 into the numerator, I get 1 minus cosine 2 theta divided by 2. So that's a sine square. So those two are actually the reduction formula that we can use to reduce the power of a given expression. Let me just rewrite them. So we get sine square theta equals 1 minus cosine 2 theta over 2. And the cosine square theta is equal to, instead of writing as cosine plus 1, I'm going to write as 1 plus cosine 2 theta over 2. The only difference between those two equations is the operation in the numerator. One is addition, one is subtraction. But they all coming from the cosine double angle formula. Now, in the book, there's also a tangent formula. I'm not even going to write it down. But if you want, you can try to think about tangent square theta is equal to sine square theta over cosine square theta. So that's going to be 1 minus cosine 2 theta over 2 divided by 1 plus cosine 2 theta over 2. Now, since both of them divide by 2 in the numerator and denominator, so we can just multiply by the reciprocal, or we can just take a shortcut, which is multiply the numerator by 2 and the denominator by 2. So basically multiply by 2 over 2. And that way the denominators in both numerator and denominator got canceled. And we just end up with 1 minus cosine 2 theta and 1 plus cosine 2 theta. I would say, personally, I don't really recommend memorize. Obviously, that's a benefit if you memorize all of them, but I personally never memorize them. But I always remember that in order to get sine squared or cosine squared, I'm going to use the cosine double angle formula and just derive it directly. That way, just if I need it, I can find it that way. I didn't memorize those identities, but you could if you want to. All right, so let's look at some examples. So we're going to use the reduction formula, which reduction formula is here. Reduction formulas to write cosine to the fourth power of x as sines and the cosines such that their highest power not greater than 1. So we're going to take cosine to the fourth power of x, and we're going to write it in terms of sine and cosine. But the power of the sine and cosine terms, the 1 at maximum. They're not going to be squared. They're not going to be cubed. So let's begin with cosine to the fourth power x. You can either think about as cosine squared times cosine squared, or you can think about as cosine squared and then square everything. It's up to you. It doesn't really make a lot of difference. So suppose, let's just see, we want to write it as cosine squared x squared. And using the formula earlier, the cosine square x that one, we can write it as the one above. We can use that one directly. So that's going to be 1 plus cosine 2 theta over 2 squared. And now we're just going to square the numerator and denominator. So that's going to be, I'm going to actually bring the 2 outside. So that's become 1/4 times 1 plus cosine 2 theta squared. So that's a 1 squared plus 2 times 1 times cosine 2 theta plus cosine squared 2 theta. So we drop the force power there, no more force power, but the thing we have is we have 1/4 times 1 plus 2 cosine 2 theta plus cosine squared 2 theta. But we still have a square term, and we don't want the cosine term to have a power more than 1. So what we have to do is we have to take this cosine squared 2 theta and then rewrite it again, use the same formula earlier for cosine squared. So let me just keep the other term. So that's 1/4 times 1 plus 2 cosine 2 theta plus, so for this last term, cosine squared 2 theta, so that's going to be, remember cosine squared theta is 1 plus cosine 2 theta over 2, so we double the angle. So this becomes 1 plus cosine 2 times 2 theta over 2. So now if we simplify and distribute everything, so we get 1/4 1 plus 2 cosine 2 theta plus 1/2 plus 1/2 cosine 4 theta. And then the 1 and the 1/2 I can combine, becomes 3/2 times 1/4. And then, so that's a 3/8 plus 1. All right, you know what? I'm going to take a couple of steps because it's getting confusing. So 1/4 times 3/2 plus 2 cosine 2 theta plus 1/2 cosine 4 theta. Now I'm going to distribute the 1/4 into there. So I get 3/8 plus 1/4 times 2, so that's a 1/2 cosine 2 theta plus 1/4 times 1/2, so that's 1/8 cosine 4 theta. So now we just have a sum of cosines, and there's no power that's more, no cosine has a power more than 1, although the multiples of theta increased in the cosine function. Any questions on this? All right, so that's a reduction formula. And here we have another one. So the second example I have is, we're going to verify this identity or prove this equation, which is sine cubed 2x is equal to 1/2 sine 2x times 1 minus cosine 4x. We want to show that's true, or maybe show it's not true. So again, this one, you might think, well, okay, let's begin with the right-hand side. You could, but it's difficult, at least from my experience, it's difficult to figure out what this part is. So what we're going to do is we're going to begin with the left side using the reduction formula. So we get left-hand side equals sine cubed 2x, which is equal to, I'm going to break that down into sine 2x and the sine square 2x. And the sine squared, I'm going to rewrite it using the formula earlier for sine squared, which is 1 minus cosine 2 theta over 2. But the sine 2x, I'm going to leave it because it looks like in the right-hand side, we keep a sine 2x. So I'm going to leave it there. So we get sine 2x times 1 minus cosine 2 theta. And if this is my theta, so now I have twice of that. So 2 times 2x. And all divided by 2. So I can bring the half in front and just rewrite all the terms. So sine 2x is the same term. And then times the numerator become 1 minus cosine 2 times 2x, 4x. There you have it. This is equal to the right-hand side. It didn't really add a lot of work in the process. All right, any questions on this? Again, all those problems, either you're going to have to know the formula, right, the correct formula, and the one to apply it. And then you just have to be careful with all the terms after you apply those formulas. All right, so that's the reduction formula to get sine squared and a cosine squared. Now, the next thing we have is called the half angle formulas. So suppose earlier we had, so recall, we had sine squared theta equals 1 minus cosine 2 theta over 2. So that's what we had earlier. And what we can do is we can take square root on both sides. So I get sine theta equals plus minus square root 1 minus cosine 2 theta over 2. I don't know if it's positive or negative, but that's what sine is. But what I'm going to do next is I'm going to replace. So we're going to let theta equals alpha over 2. That means 2 theta equals alpha. So now I'm going to replace the theta with alpha so that we get sine alpha over 2 equals plus minus square root 1 minus cosine alpha over 2 times 2. So that's just alpha, and then all divided by 2. So this is what we call the half angle formula. Because if we know an angle that's half of another angle, then we can apply this formula to find it. And similarly, the two other formulas, one is for cosine half angle formula, cosine alpha over 2. That's going to be plus minus square root of 1 plus cosine alpha over 2. Again, it's just like the previous one. We just take the cosine square and then we take square root on both sides and then substitute theta for its with alpha over 2. And also there's the tangent alpha over 2, which is going to be plus minus square root of 1 minus cosine alpha divided by 1 plus cosine alpha. You can think about that coming from tangent square theta formula, taking square root on both sides and substitute for the angle. To be honest, I think you should memorize at least one of them, or at least know where they come from. I think if you understand the derivation from the sine squared formula, then this should be okay. but I'll let you decide whether you want to memorize them or not. But I just want to kind of go back a little bit. So the double angle formulas you have to memorize. So the sine 2 theta, cosine 2 theta, you have to memorize. The sum and the difference of angle formulas, you have to memorize the sine alpha plus beta and the minus cosine alpha plus beta, and also cosine alpha minus beta. So those are sort of like the one that you showed up a lot. The sine square, cosine square, to be honest, even if you don't memorize it, you can always look it up when you need it. Same thing with the half angle formula. Let's see. So let's look at a couple examples. So the first one is we're going to find sine 15 degrees. Now, in the past, when we find sine 15 degrees, we could use the difference between 45 degrees and the 30 degrees, which is sine 45 degrees minus 30 degrees. That's one way. Now, the second way is that we can think about, okay, 15 is half of 30. So we can say sine 15 degrees. This is the method 2, which is sine 30 degrees over 2, where 30 degrees is corresponding to the alpha in the formula. So sine alpha over 2, so that's like 30 degrees here. And now we just apply the formula, which is plus minus square root 1 minus cosine 30 degrees, and all over 2. Right? And that's going to equal to plus minus, we already know cosine 30 degrees, which is root 3 over 2. We get 1 minus root 3 over 2, and then everything over 2. It's not going to look pretty here, but it's fine. And I'm just going to simplify the numerator and then simplify with the denominator too. So that's going to be plus minus square root of 1 minus root 3 over 2. And then that's going to be 2 over 2 minus root 3 over 2. And all divided by 2. So that's equal to plus minus square root of 2 minus root 3 over 2 divided by another 2. So that's times 1/2. So that's plus minus square root 2 minus root 3 over 4. And then we can take a square root of the denominator. So we get plus minus square root of 2 minus root 3 over 2. And you probably wonder, okay, is this going to be positive or negative, right? Because when we just apply the formula, we get plus minus. Well, we can think about the angle. 15 degrees is in the first quadrant. And the sine and the cosine both are positive there, right? Because this angle, if we use a unit circle, the y coordinate of that point is positive. So we're going to have to keep the positive value. So that's going to be positive root 2 minus root 3 over 2. I have to say though, I'm going to go back to check this method. I want to make sure everything's correct. Double check, make sure I use the correct formula. All right, so it's 7:10. Let's take a quick break for about 10 minutes, and then when we come back, we're going to continue with our lesson. There's a few things I need to talk, but it shouldn't take too long after the break. All right, so let's take a 10-minute break, and we'll be back by 7:20. All right, welcome back. Let's continue with our lesson. I have a few things to talk about. All right, so the next example I have related to half angle formula is, let's see. So given that tangent alpha is equal to -8/15, with alpha in the fourth quadrant, so we have the tangent, but we want to find cosine alpha over 2. So we want to half angle of alpha, and we want to find a cosine of that. And in order to do that, well, we're just going to use the half angle formula, which is equal to plus or minus square root 1 plus cosine alpha over 2 underneath the square root. And from here, we don't have a cosine alpha. If we have it, then we can just plug in directly. But what we have is tangent alpha, which is -8/15. So if we look at the xy coordinate and the graph the angle alpha, and we're going to create a right triangle. And the opposite side is going to be 8, adjacent side is going to be 15. So I'm going to say this is 8, this is 15. And if I want to find cosine, I need to know the hypotenuse. So we got 8, 15, and to find the hypotenuse, so hypotenuse squared equals 8 squared plus 15 squared, and then we can find those two numbers. I should not have picked those big numbers. Oh, wow. All right, let's quickly do this. That's 64 plus 225, so that's going to be 289. And if we take square root of 289, I believe is that 17 squared? I'm just going to quickly double check to see if it's a good number. And then 7. Oh, wait a minute. I'm not even doing it right. Jesus. I'm going to use Google because I'm not thinking straight. So 17 times 17. Yep, 289. You probably already memorized. Some of you know that. So that's 17 squared. So the hypotenuse is going to be 17. And from here, we can write down cosine alpha is going to be adjacent 15 over hypotenuse 17. And let's check the sign, make sure it's correct. It's in the fourth quadrant. So the x coordinate of this point is positive, so we get positive 15 over 17, so that's good. So now we can take this, put into the formula for the half angle here, so that's going to be plus or minus square root 1 plus cosine alpha, which is 15 over 17, divided by 2, and we just have to be careful simplifying. So that's plus minus square root of the 1 is become 17 over 17, plus 15 over 17, and all divided by 2. So that's going to be plus minus square root 17 plus 15, that's 32 over 17, divided by 2, multiplied by half in the next step. We got plus minus 32 over 17 times 1/2. So we got 16 over 17. And 16 is 4. So, square root of 16 is 4. So we get plus minus 4 over square root of 17. So if we get rid of the square root in the bottom, so we get plus minus 4 square root of 17 over 17. Now this is a plus and minus, so we have to decide here whether we're going to choose the positive or the negative, right? It's not, so don't just assuming because cosine alpha is positive, assuming cosine alpha 2 is also positive. We cannot make that assumption. So here we have to think about, because the angle is in the fourth quadrant, so the angle alpha is going to be between 3 pi over 2 and the 2 pi. And what about half of alpha? Well, if we just take all three sides of this inequality divided by 2, so if we all divide by 2, so we get alpha over 2 in the middle, and then we get, let me erase this, use a different color. So we get alpha over 2 in the middle, which is going to be greater than 3 pi over 2 divided by 2, so that's a 3 pi over 4, and it's going to be less than 2 pi over 2, which is pi. So alpha over 2 as the angle is actually going to be from 3 pi over 4, which is here, and a pi. So it's actually somewhere in this part. So that's where the angle alpha over 2 is. Now, if the angle is in the second quadrant, the cosine is actually negative. So in this case, we don't pick the positive, we pick the negative for square root of 17 over 17. So be careful with this choices. All right, any questions on this example here? So again, it's if you think about it, it's really coming down to applying the formula, right? The correct formula. Once you know the correct formula to use, you just have to be careful to find the correct missing part in the formula and to put it back in there. And always double check the sign, make sure everything's correct. All right, if you don't have any questions, I'm going to move on to the next section. That way tomorrow we don't have a lot to talk about. Well, tomorrow will be review, but there'll be something I'm not going to finish today. I'm going to try to finish it tomorrow, and I might go over a little bit more on the next section just to make it easy for the following week. As you know, that next week is the last week. All right, so the next topic I have is called sum to product and product to sum formulas. It's a lot of terms here, but once you see the example, you kind of recognize what kind of problem will be related to this. So what this one says is that for the sum to product formula, it's like if we have sine A plus sine B, can we write it as maybe sine of something times sine of something, or maybe sine something times cosine of something, something like that. So that's the sum to product formula. And the product to sum formula which is going to be, let's just say we have sine and the cosine, and we want to write it as sine of one angle plus sine another angle. So that's product to sum formula. We're going to look at mostly that part. All right, so I'm just going to remind you what we had earlier. So recall earlier we had, let's see, sine A plus or minus B, that's equal to sine A cosine B plus cosine A sine B. And if we have a subtraction, we just have a subtraction. And you know what, I'm going to expand this because it might be easier that way. So sine A minus B is equal to sine A cosine B minus cosine A sine B. That's the first one, that's the second one. All right, I'm going to write down the cosine part later. So the first example is write sine x plus y cosine x minus y. So that's a product as sum of trig. So as a sum of sine and cosine, all cosine functions. So how do we do that? Well, you probably think, okay, do I go in there and replace sine x plus y with the first formula and the cosine x minus y with the equivalent cosine formula? You could, but that's not the way I'm going to take. Because if we do that, we might end up with like a messy, because we have two terms for each, we multiply, we get 4 terms. And each of them has is a product of 2 trig functions. So it could be really messy. So the trick here is to actually think about, don't worry about the x plus y or x minus y. Just think about, here we have sine of angle, let's call this A. And then we have cosine of a different angle, let's call maybe B. So we basically have sine A cosine B, and we want to rewrite that as the sum of trig functions. So, okay, how do I get sine A cosine B? If we go look back 2 lines above, so we get the first and the second formulas. So we get sine A plus B and the sine A minus B. And then the right side, we have this like products. If we just simply add them, so if we add the 1 and the 2 I wrote earlier, the first and second equation, as you can see, when we add them, those last 2 terms, they will cancel because one is positive, one is negative, and that gives me sine A cosine B remaining as a product. So that's what we're going to use. We're going to add equation with 1 and 2. So add 1 with 2. And the cosine A sine B in both parts, they cancel, become a 0. So I get sine A plus B plus sine A minus B on the left. And on the right side, I get twice sine A cosine B when we add them. And there you have it. You have sine A cosine B. So now I'm going to divide by 2. So I get sine, I'm going to write the right-hand side to the left. So I get sine A cosine B equals 1/2 sine A plus B plus sine A minus B. So this is what they call the product to sum formula. But again, I just want to show you how we get it. You really don't need to memorize the formula. If you have sine times cosine, just think about, okay, I need the sine A plus B, sine A minus B formula, add them together to get the sine A cosine B part. And with this set, and now we can actually rewrite the given problem using this new formula. So sine x plus y cosine x minus y. So that's going to be 1/2 sine A is x plus y. So this is the A, this is the B. So a plus b, so that's going to be x plus y plus x minus y, and then plus sine a minus b, which is going to be x plus y minus x minus y. And that's going to be 1/2 sine of 2x, because the y become canceled, and then plus sine. So we get x plus y minus x plus y. So we get positive 2y. There we have it. We get 1/2 sine 2x plus sine 2y in a bracket. So that's the product to sum formula we used. Any questions on this? Again, like if you want, you can choose to memorize this one. But I personally don't recommend it. I would say just always memorize those basic ones, the sum and the difference of angle formula, because that's where this new formula comes from. It's coming from adding those two formulas or subtracting them. All right, let's look at a couple more examples on this. So the next example I have is we want to write the following: cosine 2 theta times cosine 4 theta as a sum of trig functions. So in this part, I don't have sine and cosine. I have cosine times cosine. Now, if you remember in the sum and the difference, sum or difference of angles formula, we had cosine a plus b and the cosine a minus b both give us cosine times cosine to begin with. So let me write down those two. So recall, we had cosine a plus b equals cosine a cosine b, just look like the one we had above, minus sine a sine b. And the cosine a minus b equals cosine a cosine b plus sine a sine b. So I'm going to call this equation 3 and equation 4. So if I want to get a cosine times cosine out of here, I should add them again, just like before. That way the two products with sine a sine b will cancel. So if I add them, I get cosine a plus b plus cosine a minus b. So this is equation 3 plus equation 4, give me. And the right side, I'm going to get 2 cosine a cosine b. And remember that those two, they cancel because one is positive, one is negative. Now I'm going to divide by 2 or multiply by half. So I get cosine a cosine b equals 1/2 times the terms on the left, cosine a plus b plus cosine a minus b. So this is, again, this is a product to sum formula. You can memorize it or you don't have to memorize it as long as you know where they come from. I don't memorize those formulas. I was never told to memorize them. And when I needed to use them, it's always think about going back, okay, I have this sum of angles formula or difference of angles formula. So now we can use the same thing for cosine, for the example we had. So cosine 2 theta cosine 4 theta, that's going to become 1/2. So here we just have to think about, okay, the 2 theta is kind of like the angle A, 4 theta is kind of the angle B. So we get 1/2 bracket cosine A plus B, so that's a 2 theta plus 4 theta plus cosine A minus B, that's 2 theta minus 4 theta. And that's going to be 1/2 cosine 6 theta plus cosine negative 2 theta. And we usually don't like to leave a negative angle there. So it's going to rewrite it. So that's going to be 1/2 cosine 6 theta plus, now if you remember cosine of a negative angle, cosine negative x, so recall cosine negative x equals cosine x. So that's just going to be cosine positive 2 theta. Any questions on this example? Okay. All right, so the next example I have is we're going to evaluate sine 11 pi over 12 and sine pi over 12 times. So sine 11 pi over 12 times sine pi over 12. And obviously no calculator, we want to find the exact value. So without a calculator. And if we look at it, you know that 11 pi over 12 is not a nice angle. Same thing with pi over 12 is not nice, right? So we have a sine, a product of two sines of two angles that's not nice. So this is where we have to convert the sine, the product of the sine into a sum, and maybe that's going to make it easy. So how do I get sine times sine? Well, earlier we had cosine times cosine. Sine times sine is also going to relate it to the equation 3 and 4, because that's the only place we have sine times sine. But I don't want them to cancel. I want to keep them. So what we're going to do is we're going to take equation 4 minus equation 3. If I take 4 minus 3, the positive minus the negative become a positive. So that's what we're going to use. Let me copy this. I'm just going to paste this here. So recall we had those two formulas. And let me erase this. So we had addition here. And in this case, I want to keep the sine product, and I don't want the cosine product to be there. So I'm going to take equation 4 minus equation 3. On the left side, I get cosine A minus B minus cosine A plus B. And on the right side, the cosine products will cancel when I subtract. But then I have sine A sine B from 4 minus a negative sine A sine B. So that becomes addition. So this really becomes 2 sine A sine B. And from there, I'm going to divide by 2 on both sides. So I get sine A sine B, move it to the left. So that's equal to 1/2 bracket cosine A minus B minus cosine A plus B. So that's the formula for sine A sine B. Now you can memorize it, or you, like me, just look at where they come from. And now we can actually apply this formula to the problem, which says sine 11 pi over 12 times sine pi over 12. And we're going to take this and put in there. So that's become 1/2 cosine of A minus B. A is 11 pi over 12 minus pi over 12 minus cosine of A plus B, 11 pi over 12 plus pi over 12. At least one of them is extremely easy now. So now we have 1/2 times cosine 11 pi over 12. That's 10 pi minus pi over sorry, 11 pi over 12 minus pi over 12, so that's 10 pi over 12, which is 5 pi over 6, which is not too bad, minus cosine of 11 pi over 12 plus pi over 12, that's a 12 pi over 12, which is pi, which is actually really nice. So let's see, we have 1/2 cosine of 5 pi over 6 for the first angle, and then minus cosine pi. We need to figure out each one of them. So I'm going to use unit circles here. So cosine 5 pi over 6, pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2, 4 pi over 6, 5 pi over 6. So I get the angle here. And the reference angle is going to be 30 degrees. And the cosine is going to be the x coordinate of this point. And that because it's 30 degrees, reference angle, so I know that this is a half, this is √3 over 2, but it's in the negative x direction. So it's negative √3 over 2, that's cosine. And for the pi, so angle pi is right here. And I don't even need to create a right triangle because for this particular point on the unit circle, I know that the x coordinate is going to be -1, the y is 0, I don't care, but I only need the cosine. So there I have two cosine values. So I'm going to plug them in. So I got 1/2 cosine 5 pi over 6 is negative √3 over 2, minus cosine pi is minus -1. So I get 1/2 times negative √3 over 2 plus 1. If you want, you should simplify this. So that's going to be 1/2 times negative √3 over 2 plus 2 over 2, which is 2 in the numerator. So we get negative √3 plus 2 over 4 at the end. So this particular problem with our calculator, obviously, it takes a lot longer, but it's kind of nice because it brings back quite a few concepts. One is you have the sum and a difference of angles formula, and then you can combine them to convert them into a new product to sum, or in this case, product to difference formula, it doesn't matter. And when we apply them to the example, it's reducing the complexity of the problem to some angles that we actually know we can find the cosine of. And then we need to use a unit circle. At least for me, I have to use a unit circle. You probably have it memorized, which is great. But if you didn't, feel free to use a unit circle to find the corresponding cosine values. Now you just put them back in and solve the problem at the end. Okay. Any questions on this? So I always look at this type of problems. It's kind of like earlier, remember we had a sine 105 degrees, the very first example. It's the same. You just want to take this angle that you don't know how to find sine or cosine of, and then you try to break it down into two angles that you know what to do. Similar here. So if we have a product, we don't know what to do with each angle. We can try this approach. All right, so let's see. I'm going to quickly, I think there's another approach to this problem. I'm going to quickly check. So let's see, pi over 12, that's 180 degrees over 12. That's 15 degrees. So I was just thinking, like, for a different approach to this problem, suppose you were just given this, you don't know what to do, right? Because it's a product. You can try with separating each angle, because pi over 12 is 15 degrees. So you basically convert this into sine 11 pi over 12, that's 11 times 15. So that's 15 times 11. So we get 15, we get 165. So sine 165 degrees times sine 15 degrees. So that's a given problem in degrees. And from here, what you can do is you can try to break the problem into nice angles. For example, 165 degrees. Let me just double check, make sure everything's correct. So the first one, you can break that down to sine of, I don't know how you break down 165, maybe 120 degrees plus 45 degrees. And then the second one, we're still multiplying. Sine 15, again, you can rewrite this 15 as 45 minus 30 degrees or 60 minus 45, it's up to you. And from here, we just have to apply the sum and the difference of angle formula twice for each one of them. It should be able to give you the correct answer at the end. Suppose you didn't like the other way I did. So that's going to be just a sine, cosine, plus cosine, sine. And that's one part. And then you have to multiply with the second one, which is a lot longer and more terms, but it should give you the right answer at the end. All right. So there's another formula. I did not write it down. So what we did, let's see, we had equation 1 and 2. So if we add them, we get sine A cosine B. But if we take 2 minus 1 or 1 minus 2, we can get cosine A sine B. I did not write that down. That maybe I'll just put it above here. Well, actually, let me write down at the end. Wait a minute. Let me copy this. So if we continue with equation 1 and 2, so recall we had this. That's equation 1 and 2. Earlier we add them to get the sine A cosine B. But if we take 2 minus 1, sorry, 1 minus 2 in this case, make it easier because we want a positive. So if we take the first one minus the second one, when we subtract, this plus minus a negative become 2 plus, and the sine A cosine B will cancel when we subtract. So that's give us sine A plus B minus sine A minus B. And like I said, the sine A cosine B will cancel. We have cosine A sine B minus a negative cosine A sine B. And that becomes 2 cosine A sine B. And divide by 2, so we get cosine A sine B, which is equal to 1/2 of sine A plus B minus sine A minus B. So that's the force products to sum formula or products to difference formula that we didn't use. I just want to show you that there are 4 of them, but they're all coming from the basic 4 formulas, the sum and the difference of angles formulas. I personally don't recommend memorizing them, but I do think you should know. Like if I give you a problem, for example, if I give you this problem that sine 11 pi over 2 and the sine pi over 12, if you want to solve that, and I think you should be able to do it as long as you have the sum and the difference of angles formula memorized. All right. So there are a lot of formulas, that actually more formulas to come. And don't really try to memorize every formula that the book says. It's really no point. And to be honest, like when you really need it, how often do you really need it, right? When you need it, you can always find it. All right, any questions at this point? All right, any questions about what we did today or anything that perhaps not related to what we did today, like about the exam coming up? So tomorrow, there's more stuff that I need to finish. So I'm going to try to finish a little bit more tomorrow and bring any questions you have. We can go through them as a review in class tomorrow. And there's exam on Monday. And the next week will be the last week. So exam on Monday, we still have class Wednesday and a Thursday. I'm going to try to go through a little bit more of next week's material tomorrow. Probably not a lot. I don't want to give you too much information to I guess to worry you about now. But I do want to kind of get ahead a little bit so that next week it's going to be a lighter week in addition, other than just the exam. I already post the homework for this week. I did it last night pretty late. You probably haven't got a chance to look at them yet. So do your best on those. And the next homework that's due Friday, the next Friday at 8 p.m. If you can, try to get ahead with them if you know how to do them. But if not, after the exam on Monday, definitely work on them because you don't want to ask for extension because you're not going to get one. I'm sorry. That's just something I cannot allow. And the same thing with this current homework or any previous assignments that you have not finished. You should finish them. So everything has to be done by next Friday. Let's just put it that way. Like exams, homework, everything must be completed by that time. That way I can submit the grade. That's not the rule set by me, unfortunately. That's a rule that I have to follow as well. All right, any questions? All right, again, just one more time, do not ask for homework extension next week. Not gonna happen. All right. All right, and on that note, I'll see you tomorrow. Take care, everyone.
Thanks.
All right, have a good night. Bye-bye.
Thank you.
Take care.